Okay, so moving on here. All right, so now we're talking about perpendicular, right? So you have two lines that are perpendicular if the product of their slopes is -1. Product of slopes is -1, okay? And again, vertical and horizontal line are always perpendicular. So when we think of perpendicular, we should think of making right angles, right? So these two lines should make right angles. Now let's just a little suppose over here. So let's suppose that the slope of line P is -3/2. Well, if we take -3/2 is the one slope, and we multiply it by the slope of line Q, you should get -1. Well, I want to solve for the slope of line Q. Well, I'm going to get rid of this -3/2 by multiplying by its reciprocal. -2/3 times -2/3. The -2/3 and -3/2 will cancel, and we'll get the slope of line Q by itself. And over here, when you multiply -2/3 by a negative, it turns into +2/3. And there are your two slopes. -2/3 and +2/3, or -3/2 and +2/3. -3/2 and +2/3 are what we call opposite reciprocals. That is the major relationship between the slopes of your perpendicular lines. They are opposite reciprocals. In general form, if one slope is A over B, then the other is going to be the negative B over A. Those are opposite reciprocals. So that's what we're looking for when we're talking about perpendicular lines. All right, so let's do a couple examples involving some perpendicular lines. All right, it says, are lines J and K perpendicular? All right, so where are J and K? Well, this looks like J right there. This looks like K right there. So let's go with J first. Again, remember, rise and run. So I'm going to find two nice points on J. Here's one, and here's one. So I'm going to go, so I don't like to go to the left. I'd like to go to the right. So I'm going to start up here. I'm going to go down 1, 2, 3. So down 3, and then right 1, 2, and right 2. So the slope of line J, that's my cursive J, sorry, it's terrible. I usually make it like this, J. So the slope of J is -3/2. And now I'll do K in blue. So K is over here. So here's a nice point. That looks like a nice point. Again, I'll go up 2 and right 3. Slope of K is a +2/3. And look at that. -3/2, +2/3. Just like my example above, these are opposite reciprocals, and therefore these two lines are perpendicular. If you look at where lines J and K intersect, they intersect right up here, okay? JK, and this does appear to be a right angle. Okay? Very good. All right, last problem here. It's two-parter. Okay, so part A, it says, what is an equation of the line through point P that is parallel to line L? So in this problem, we need to find the line parallel to another line. Well, when you see parallel, immediately think of equal slopes. Okay? Now, from this picture, I can grab two things. First, I can grab a slope. The slope of this line, because they give me the equation, is going to be 1/2. Remember, that's mx. The slope is m. So our slope is 1/2. Because our line is parallel, we're going to use that slope of 1/2. Then they give me a point for 1. That is going to be my, or those are going to be my x1, y1 in point slope form. Don't know if you recall point slope form, if you've been taught it, but there you go. This is going to help give us the line that's going to be parallel, and I'll draw it through here. That's going to be parallel to our line. Okay. All right, so point slope form, y minus y1 equals m parenthesis x minus x1. So we're going to do y minus, and y1 is 1, equals m is 1/2, x minus, and x1 is 4. We're going to go ahead and distribute the 1/2. So y minus 1 equals 1 half x is 1 half x. 1 half of negative 4 is negative 2. And we'll add 1 to both sides. Y equals 1 half x. Negative 2 plus 1 is negative 1. And there we go. There's our equation. If you take a look at our picture here, here's our y-intercept of negative 1. We go up 1 and right 2. So you can see I'm a little bit off. I'm going to erase this just so you can see it more clearly and accurately. So negative 1 here, up 1, right 2, up 1, right 2. And we land right on the dot. And there is our line. That's parallel. Perfect. Okay, same line, same point, 4, 1, but now let's go perpendicular, okay? So now we have to think of, okay, opposite reciprocal slopes. So if this slope is 1 half, again, same equation, then our slope must be the opposite reciprocal. So that means you make positive become negative, and the 2 goes on top, the 1's on bottom. That's just the slope of negative 2. Our point is still 4, 1. That's still going to be our x1, y1. And now we do point slope form all again. Y minus y1 is 1 equals negative 2 times x minus, and x1 is 4. We're going to distribute the negative 2 this time, no fractions, which is nice. So we get negative 2x, and negative 2 times negative 4 is positive 8. And we're going to add 1 to get the y by itself. And we'll get y equals negative 2x plus 9. Now, unfortunately, here I don't have a 9 on my y-axis, but I can use this point and count the slope of negative 2. That would be down 2 and right 1. It could also be up 2 and left 1. And you can see that if I connect these points, there's your right angle. And again, hopefully, way up here at 9, that's where it would cross the y-axis. And there you go. Great. So a little bit of algebra here, right? Fun times we live in that. But again, parallel lines, equal slope, perpendicular lines, opposite reciprocal. All right. Thanks for watching. Good luck on the homework.